All right, welcome back to part 2 of Tic-Tac-Toe. In our last video, we created a constructor, we wrote a move method, and then we have a toString, so we can actually see the board. So I'm going to run what we got real fast just to catch you back up. But initially we see the board. That's coming from this print statement on line 6. We then see the word true, and that is because our move method is returning a true or false value. True meaning that the move was successful. In this case, we're trying to let player X move to space 5. Okay, well, space 5 is available, so that move is successful. We can print off the board and see that X is there now. I then try to move player O to that exact same space. Well, it's occupied at this point, so we get a false value, and notice that our board is unchanged. So this is the gist of what we coded in our last video. We're going to pick it up from there, and let me reference the end product, our demo code here. Right, when our game starts, we're going to see the initial board, and we just say player X, choose a space. Player X is going to type in some number 1 through 9. They get to move there if it's successful, and then we swap players. So a couple things we're going to need: scanner. We're also going to need to track whose turn it is. And if I were to do something like, play out this game, eventually there's going to be a game over. So we'll announce that and we'll actually display the board. Okay, so eventually we'll have a game over method. Let's get started. So a lot of what we're about to do is just going to take place in the driver. I'm going to basically get rid of everything except the creation of my tic-tac-toe game. We're going to need scanner for this. So let's bring in scanner. I'm jumping straight to step 2, which is where I make scanner input is equal to a new scanner. Hitting enter along the way allowed me to auto import scanner. So this is technically step 1, right, of how we implement scanner. And we're going to read from system.in, the keyboard. Now, it doesn't matter if this is before or after the creation of our game. We just need to do it before we create our loop. Another thing I'm going to create here is the player, so we can keep track of whose turn it is. I'm going to simply create a char called player, and initially X is the first player, so we'll create that. Okay, I'm ready for my loop, and we're going to say while the game is not over. That is game.gameOver is false. So while the game is not over is how I'm reading this. Okay, this is red. This is red because we actually don't have a game over method yet. I'm going to show you something super slick with IntelliJ. You can hover over this red text, hit Alt-Enter, and it's going to give you some suggestions. The top one here, create game over method in TicTacToe. I want that, so let's choose that. We immediately jump to the TicTacToe.java class. We see that we have the game over method with no args, and it returns a boolean. How does it know to do this? Well, for one thing, we're calling the method game over here. We're saying that there's no arguments, and so that seems pretty easy. What's interesting to me is that it knows we want to return a boolean due to the context, right? This is the condition of a while loop. And so it can actually determine that we want a boolean. For right now, I'm going to plug in a dummy value, right? We're just going to return false. So in theory, this loop will go forever, but we're going to come back. We're going to add our conditions for when the game is over. Okay, so while the game is not over, right? We're going to get a position from the player, a space they want to move to. Okay, before we do that, let's print off the board. So I'm going to print off game. So we're going to see what the board state is. If you recall in our demo code, the first thing that happened whenever the game started is that we see the current board. Then it's time for the current player to make a move. Right? So we need to basically get that space from the user. So I'm going to create integer space, and that's going to be input.nextInt. Okay, we're going to perform that move. That is, we'll take our game and move. The current player will move, and they're going to go to the space that they entered. Okay, that iteration will end, and we would, in theory, see the game all over again. So this is kind of the gist of our driver. I'm going to run it. We got some issues, right? We got to change the player, but not always. So right away, we see our board. I can hit this stop button, which means that my code is running. It's actually waiting here. So even though I'm asking for user input, I didn't prompt them. Let's go ahead and make a move anyway, where I do like a 5, and we see that's actually working, right? We put X there. A new iteration started where we get to see the game all over again. We can, in theory, go there. It's still on player X, and so we got to determine a swap there of players. So let's stop. Let's fix our issues. First one, we need to prompt the user. We'll say something like player plus whoever the player is. Choose a space. Okay, then we'll actually get that space for them. And then we're going to make a move. Now, where this gets interesting is that sometimes we want to swap players. After we make a move, it should be the other player's turn, but only if the move is successful. How do I know the move is successful? Well, we wrote this so that the move method returns a Boolean value in the event that it is successful. That is, if this is true, not only is it going to attempt to do the move, but in the event that the move is successful, it'll do the move and return a true value, at which point we're ready to swap the player. That is, player will then become player O. Otherwise, if we hit this else, that means that effectively the player doesn't change. The player should be X. And I believe we can actually... It's not so much that the player doesn't change. Realities are, I need to do this swap based on not only if it's true, but who the actual player is. Right? So, we're actually going to add more to this. If this is true, I'm then interested in detecting who the player is. If the player is X, we're going to make the player O. Otherwise, we'll leave the player as X. Okay, so the way this reads is, if this is true, the move is successful. If the current player is... So if this is true, I need to swap. If the current player is X, they become O. Otherwise, it must be player O, so they become X. That's all we're doing here. Okay, you could kind of condense this down. One thing, we actually technically don't need these braces, but as you can see, that looks a little bit messy. But all of this hinges on the fact that our move method, instead of just making it void, we're actually returning a true or false value. We added functionality to a method that otherwise wouldn't have it. Okay, so let's take a look again at our loop. If the game is not over, we'll print off the current board. We'll ask the current player to choose a space. We'll get that space. We'll attempt to make that move. If this gives me a true value, I'm going to enter this if statement and then swap the player depending on who the current player is. If this is false, we just skip it. That's the end of the iteration. We'd come back up and we see the game board all over again. Let's try this out. I'm going to tell it to run. We see player X choose a space. I'd like to put some spacing here in between the board and the actual player. Player X chooses a space. Player X is going to go 5 because he's big brain. And then we see it swaps to player O. Let's make player O go to space 8. That looks pretty good. We're back on player X. Let's say player X tries to go to spot 5. Well, that's not available, right? So this board and this board are the same. No changes. Notice also it's still player X's turn. We would skip over this if statement because we get a false value here. And we would just try again. Okay, I'd like some spacing before and after this, and I'd also like this print to just simply be this print line to just simply be a print, so that the player's choice actually ends up on the same line. How do we get the spacing before and after this? what I actually recommend, what is actually super easy, is that we add new lines to this statement. And let me run it again, and I'll show you what we got. Here's our board. It's player X's turn. They go 5. 8. 4. 6. Sure. I'm just going to finish this out. And so here would be a situation where the game's over, right? This is a draw. So we need to finish out our game over method before we continue on to the next little bit. Okay. Right now, our game over is just returning a dummy value. Here's what I want you to think about. In some ways, there's 3 states that the game is over. Either player X wins, player O wins, or the game is a draw. I like to think about it as potentially 4 states in which the game is over. A player has won horizontally via the rows. They have won vertically via the columns, diagonally, or it's a draw. So what I'd like to do is make effectively a game over method for each of those 4 situations, and then just code for those. Instead of trying to make this super cumbersome game over method that tries to check for all 4 situations simultaneously, we kind of compartmentalize it, right? We wrap those things up in methods. What am I saying? Let's make a game over like rows. Game over via the rows. So we're going to say, is the game over via rows? Or is the game over via columns? Or is the game over via cat, like a draw? Or, last one, let me see what did I actually call it? Did I spell out diagonally? Game over diagonal. You could call this game over tie. I like that a little bit more. Or game is over diagonal. Okay, so what I'm going to do is code each of these checks individually in their own methods. All of these are red because we haven't wrote them yet. Okay, for now, I'm just going to comment that bad boy out. This is going to be mad at me. We can put back in our... what I'm actually going to do is, I want you to think for a moment, which of these do you think is the easiest to code? And very quickly, I think a lot of students get to either the game over diagonal or game over tie. I think game over tie is a very easy one to code because look at the situation. Right? The situation that we have a game over tie is that all the spaces are filled and we're still here. Right? So let's code that one first. Just like with the game over that I did here when it was red, I'm going to hover over this text, hit Alt-Enter, and we're going to create the game over tie method. It knows based on context that we should be returning a Boolean. It knows it should be in this class because there's no implicit parameter here. Right? It is implied this .game over. So it knows this goes in this class. Okay, how do we know we have a game over tie? We know it's a game over tie if we loop through every spot and it's an X or an O. That's a little bit difficult. We know it's a game over tie if we loop through every spot and it's not its original value. That's a little bit more what we're looking for. Okay, this is a 2D array. In order to loop through it, we're going to have to use nested loops. I'm going to plug in for I. We're going to rename that R to coincide with our rows. So we'll say as long as we are less than board.length. Inside of this loop, we'll have our for I, and I'm going to rename that C. We'll say as long as we're less than board@r.length. Again, this is a rectangular, technically a square board, so you could say board at 0 all of the rows have the same number of columns, but I would prefer we go with this. Okay. With each iteration, I'm going to ask, is this one not the original value? Okay, the original value, keep in mind, is the default value for char. If we go back and look, right, we never actually filled our board in the constructor, so the default value is still there. That default value is O. Okay. Now, one thing you might be thinking, and this is where things get a little bit tricky and where I may have considered a string instead, is that this element is a single character, right? The whole thing is, the board is a 2D char array. But the single element at RC is a single char. So I'm going to compare char to char. But what is in... Let me pull up maybe a Unicode table. The default value for char is not O the character. It's not 0 the character. It's like 0 on the table. Right? If we look at something like this, maybe a little bit hard to see on our stream or on our video, but we have like all these empty spaces up here. This is where like some super special stuff goes, you know, stuff like tab, enter, stuff that doesn't really have a character associated with it. Here we actually see the digit 0. Okay. I'm telling you the default value of char is this space here. I don't know what it is. It's like tab or enter, a new line. I don't know. So what I'm actually comparing here, I'm asking, is the current element equal to the default value? 0 on that table. Okay. If we loop through and we manage to find a default value on our board, that means it's not full. There's still a space available. So I'm going to return false because the game is not over. If we're still here and we've managed to go through the entire board, I'm going to return true. Okay, I'm going to explain that one more time. We're using our nested loops to go through our 2D array. We're looping through. With each iteration, I'm asking, is the current character 0 on the Unicode table? If it is, that means that spot's available because we have not changed it to an X or an O. If we have a spot available, there's no way the game is over in a tie. So we return false. We'll piece out of the method and we'll stop there. Otherwise, we're going to return true. Okay, so I've already plugged this in here, right? We have our main game over method, which is calling game over tie. Let's test for this. I'm going to flip back to my driver. Tell it to run. We're going to start plugging in X's and O's. 1, 2, 3, 4, 5, 6, 7. At some point, oh, I can't do that. You goofed. You goofed with. Well, technically the game is over. It thinks it's over in terms of a tie. So we see, right, this process finished. I can't hit my stop button. The game actually did end. Technically, our game over tie method worked, but that is because we ultimately filled in this last spot with an X. Okay. What we're seeing here is not the final board, right? Because I actually print off the board at the beginning of the iteration. And on the very last iteration, this becomes false. And so we exit the loop. So one thing we'll want to do is print off the final board along with like a game over message. Okay, so I would say something like, we'll create a new line and we'll say game over. We will then print off the final board so you can actually see that. Let's try our whole game over tie method again. Nine. Oh, technically, like one of them's already won. All right. So the game is over at this point. we managed to fill all of these spaces, which triggered our game over tie, even though you could see that technically X1, whatever. But we do see our game over message, and we see the final board. So that's a pretty good start. We got our loop to stop based on a tie situation. Now, the thing you may be thinking is, well, what about these other win conditions? Isn't that going to be an issue with game over tie? What we're going to do is effectively this. We're going to check for that last, right? If we manage to go through all of these and the board is full, then it must have ended in a tie. Otherwise, one of these other ones is going to trigger long before we actually check our game over tie. All right, from here, game over diagonal is probably the next easiest one because it doesn't really require a loop. All right, so I'm going to bring that one in. It is again red. I'm going to hover over it, hit Alt-Enter, and we'll create that method header. Okay. Game over tie is easy because it doesn't require a loop. All we're doing is checking, game over diagonal doesn't require a loop. We're just checking along these diagonals. I want you to think for a moment. We'll know that the game over is over via diagonal if these three spots are the same. It doesn't matter if they're X's or O's, if they're the same. Okay. I'm actually going to jump to the super efficient solution, which is let's first check the spot in the middle. We're going to see, is it not equal? Actually, we'll walk this out. All right. If board at 0, 0, that's this spot here, is equal to the spot here, which is board at 1, 1, right? The spot in the center is board at 1, 1. So I'm asking, is this one equal to this one? And it doesn't matter which one I grab, either this one or this one. We want to compare it to my last one here. Board at 1, 1 equal to, this is our second row, second element, board at 2, 2. Okay, so this is checking this diagonal. If this element is equal to this one, and this element is equal to this one, that whole diagonal is the same. That's one of the diagonals. Let's try the other one. That is, or this spot here, this board at 0, 2, is equal to this spot here, which is board at 1, 1. And I want to know, does that equal this spot here, which is board at 2, 0? So there's our diagonals, right? If this diagonal is all the same, it's either all X's or O's, or this diagonal is the same, it's all X's or O's. That's a game over via diagonals. Let's actually try that one out. Immediate game over. Why? Again, if we look back at our constructor, we made the board. It's going to assume default values. This thing, despite us seeing those numbers aren't actually put in there until we get to the toString. What's actually in the board is that Unicode 0 spot. Okay, so they are all the same initially. Okay. So one thought again is, well, let's go through the constructor. Let's actually fill it with digits. You don't have to do that. Before you check to see if the game over is diagonal, just make sure that this spot right here is something else. Make sure it is not the 0. All right, so here's where we're checking the diagonal. So I'm going to check that as long as board at 1, 1 is not that Unicode 0. If this is true, that means it's something else. That means it is an X or an O, and we're ready to check the diagonal. All right, let's try this again, and let's try to get a game over via diagonal. X choose a space. They're going to go 5. O choose a space. They're going to go 2. 1. Doesn't matter. 7. 9. And just like that, our game ends because we actually have a game over via the diagonal. All right, to make sure that that O can do it, why don't we play another quick round where O takes the 5, and we're actually going to also go ahead and test the other diagonal, right? Which means that X can go to 1, O can go to 7, X at 9, O to 3, and I have a game over via this diagonal using O. Okay, there's other test cases, but that looks pretty good to me. We just need to knock out our rows and our columns. So I'm going to do rows next because these are going to be very similar. And rows, I think, because we tend to do row major order, makes a lot of sense. This one, I would use a loop, but you don't have to use nested loops in order to do this. All we're really going to do is iterate through the rows. And then when I'm on the row, I'm going to ask, are the 3 values the same? In a similar way that we did with this. Right? So I'm going to create the loop that goes through the rows. Our rows are equal to board.length, the total number of rows. Okay, so let's say that we're on this row. I want to know, is this one equal to this one, which is equal to this one? We're going to say if board at, what is this spot? Well, the spot is 0, 0, right? But think about this. As soon as we test this row, we're going to move on to the next one, and then the next one. So I would not explicitly refer to spot 0, 0. It still is the 0 column, but the row is going to update. So out of these 2 values, this is our row. Right? So I'm going to pull the element from the current row at column 0 and ask, is that the same as board at the current row, column 1? And is that the same as the one right next to it, which is board at R2? Okay, so notice that we're basing our row selection on the variable. Initially, that's 0. So we're going to ask, is 0, 0 equal to 0, 1? Is 0, 1 equal to 0, 2? The row would then update. So we're going to ask, is 1, 0 equal to 1, 1? Is 1, 1 equal to 1, 2? If this is true, that means that all of the elements on the row are equal. It doesn't matter if they're X's or O's. We're going to return true. If we manage to go through all of our rows, oops, didn't mean to delete both those. If we manage to go through all of our rows and we're still here, that means we did not find any rows that were all equal elements. We can return false. Okay, we're going to have a similar problem to our diagonal where we get a game over right away. Why? Because the board is actually filled with the Unicode 0. Very simple. We just ask, is the first element on this row something else? Is it an X or an O? If so, we can maybe test for that. So, if board at R0, the very first element on the row, does not equal the Unicode 0, and this other stuff is true, that means we got something other than 0, and all the elements are the same. Let's try that out. Player X chooses space. They're going to go to 1. O is going to go to 4. X is back at 2. O is at 5. X is at 3. Boom. I'm going to do another one where O wins, and we'll pick a different row to show that it works. In fact, I'll go last row on this. 1, 7, 2, 8, 5, 9. It's yet again a game over. Notice that we got still available spaces. So it's not via a tie, it's via our rows. It's not via the diagonal, it's via the row. So this is it. We are looping through the row. We're checking the first element. If it's something other than a 0, then it is worth testing to see, are the elements the same? Right? If it is still a 0, we'll just move on to the next one. If we manage to find a row where all the elements are the same, we return true and stop there. Game over rows would return true. We would get true out of this statement and return a true value, indicating that the game is over. All right, we're going to do the same thing, but for columns. I'm going to bring that in. We can hover over it, hit Alt-Enter, and create our game over columns. And when I say we're going to do the same thing, I mean it's basically the same thing, except instead of looping through the rows, I want to loop through the columns. What I like about what I'm about to do is it's intuitive. Right? This is looping through the rows. Let's change that. Let's go through the columns. Okay. Technically, and this is like a test question, a quiz or test question, because it's a square board, the number of rows, the number of columns is the same. So I could just leave this at board.length, right? If it were rectangular, we would need to do board at 0. Note that board at R does not work in this context because there isn't an R. Okay, I'm going to leave it at board at 0 because that should stay a little bit more intuitive with us. If you leave it at board.length, I'm okay with that. Instead of checking the row, it's the same concept, except we're looking at the column. This is what I like so much about this, is this is super intuitive. We figured out the code one time. We're just doing it again. Instead of looping through rows, we're looping through columns. I'm going to loop through all the columns. I'm going to ask, is the element at board 0C? Initially, C is a 0, so that's this first element. Is it something other than a 0? If it is, we'll check this next one. Is it equal to the one that's underneath it? Right? That is one row underneath it at that exact same column. What about the one underneath that at that exact same column? Let's try this out. Let's try to get a game over via our columns. X is going to go to 1, O to 2. X is 4, O to 5. X is going to go to 7. And just like that, we managed to get a game over via our columns. I'm going to try it again, getting one for O. Let's go to the middle column. And there you have it. This is all of our situations. I'm going to do a tie scenario so that we see that that still works. And it works because we're checking it last, right? If I were to move it up here, we may get issues where there's actually a game over via another route, but we are ending it via a tie. Technically, it doesn't really matter too much because our game doesn't announce, who won or how the game ended, but in a way, it does matter. So let's go 1, 2, 4, 7, 3, 5, 8, 6, and 9. Here we got a game over still, and it is via a tie. That is actually going to do it for our tic-tac-toe. I'll give you one last shot of the driver, and I'll see you in the next one.